When the 468 is started up, this pattern appears in the numerical display. This is doing its self-test. If that pattern doesn't appear, then the ROM checksum has failed, or something else is wrong. And it's not always the ROMs. Another common problem is a short on the +5 storage supply. There's a separate +5 supply because the main +5 supply for the scope couldn't handle the power required by all the storage circuitry. That supply is powered through these two fuses. So the first thing to actually check, if the instrument doesn't come up at all, the first thing is to check these two fuses. They're possibly, if there's a short on the +5 supply, they would be blown. The diagnostic procedure in the manual says to replace the fuses. If they blow again, look for things, replace them. If they blow again, look for more things. It's kind of stupid. These fuses, these are called pico fuses. They're not all that easy to get, and they're hassle soldering them and resoldering them into the board to replace them. So if the fuses are blown, the next thing to check is for a short on the +5 storage supply. A TP248 on the storage display RAM board has a test point for +5, and if there's a short there, then you can start looking elsewhere for the cause of the short. One way to do that would be to disconnect all the connectors, the harmonica connectors, the main ribbon connector, the two harmonicas. If the short on +5 is still there, then the problem is on this board, but it's kind of unlikely that it would be. So we need to look at the other storage related boards. In order to get to the storage power supply and the other display storage circuitry, it's necessary to remove the back portion. This is sort of the annex, which is what makes makes the instrument longer than a regular 465. And I have not been able to get this part off without also removing the large ribbon cable. So remove it carefully. So to remove the back section, first remove their two panhead screws with the lower left. And one at the lower right, somewhat in the way of the bracket that holds the output BNCs. And 4 flathead screws on the top. Now you can carefully pull off the back section. There's some on the left, or on my left. There's a little bit of interference with another bracket, so you have to maneuver the thing carefully. You can flip it upside down, and just for security, you put the 2 panhead screws back in to a hole here. And another hole, which is a mess of cables here. You now have access to the ROMs, which are in the upper left, and if necessary, but the power supply board is underneath this assembly. So up to now I've used a number 2 POSA drive. Need to use a number 1 or smaller POSA drive. Need to remove a screw on this side. Screw on the other side. Now you can swing this assembly, this pair of boards out, and you can get some access to the, I think it's called the power supply and sweep board, digital sweep board. But if you want to replace any components on here, the board has to be removed. So the next step, go back to the number 1 POSA drive. I'm going to pull this small, there's a power cable. I'm going to pull it out just to get to the screw. And there's a pivot point on this board, and there's screws that go into these really tight nuts that are designed to keep the bolts, screws in place. Okay, now those 2 pivot screws are out. Now I can remove or pull these boards back. Get even better access to the... Now to remove the power supply board, the power supply and sweep board, you need to remove about 1, 2, 3, 4, 5, 6, 7, 8 or so, or maybe 9 or 10 440 screws with a number 1 POSA drive. You need to disconnect all the cables, and probably just as easy to disconnect the cables from this assembly and set it aside. I'll take a picture or something to record where all the cables go. You can pull the big ribbon cable out. Anyway, so you can move this out of the way. Then remove the power supply board. On the power supply board there's a test point called TP315, which is the +5, and again you can check for the short. If the short remains after you unplug all the cables from the board, then the problem is on the board. If the short goes away, the problem must be on one of the other display or storage boards. In order to service the components on the rear of the storage power supply board, it's really necessary to pull the board out of the housing that it's in. So the manual says something about 3 terminal regulators being connected with push-in connectors, but on this board, on this one, the 3 terminal regulators are just soldered into the board and bolted to the chassis. There are 2 on this side, and then there is 1 on this side. The 2 on this side have insulating washers, therefore minus voltages. They have insulating washers. This one is a plus 12 regulator and does not, well, let's see, doesn't need an insulating washer, but this one apparently has one. Wouldn't hurt to leave it on. So when you disconnect or take the screws out of the 3 terminal regulators, and when you reinstall them, be careful to reinstall the insulating mica insulators. And there's insulating washers as well, shoulder washers, so that the body or the tab of that regulator is insulated from the chassis. Okay, this is the screw from the 3rd regulator. And shoulder washer and flat washer. Now we have to remove, I don't know, 10 or so screws that hold this board to the back panel. Finally, I think I've found the last screw. I thought that was the last screw, but there's one hiding down here in the corner. Okay, I finally removed all the screws. Now the board is loose, but getting it out with interference from various things is not easy. The manual says you can just slide it out, but that assumes that you're able to get the 3 terminal regulators out of the way first. Looks like if the 3 terminal regulators weren't there, I wouldn't have a problem. So what I'm going to do is bend this one down so that it'll clear this tab. Now I can get it over. Okay. Now I have to bend this one out of the way too. Now remember that behind these 2 3 terminal regulators there are mica washers, so don't lose those. Now I've got the regulators out of the way, I can slide the board out. Finally we have the board. This is the switching power and time-based board, finally removed after some travail. And if I probe between, this test point is marked ground, and TP315, resistance is 2 ohms. and it should be hundreds of ohms. I've measured that on another 468. So there must be a short in the power supply. This is the section which is the high current 5-volt supply, because the main 5-volt supply on the main board could not supply enough current to run all the digital storage logic in the 468. So it has a separate high current 5-volt supply, which incidentally is not, the circuitry for which is not explained in the manual, but it is a what's called a buck converter. There's a switching transistor. I refer you to the Wikipedia article on buck converters to explain how they work, but a switching transistor, there's a relatively high voltage, 18 volts according to the schematic, and it's developed by this bridge rectifier and filtered and retained by this large capacitor. Then the switching transistor switches the voltage, the high voltage, through an inductor to the 5-volt output, and the on time of the inductor is would be about 5/18. You're trying to convert a 5-volt or an 18-volt to 5 volts, so the switch needs to be on 5/18 of the time. And then when the switch is off, the current still flows through the inductor, so there needs to be something to keep the current flowing, and that's this small diode. Well, actually it looks like a 3-amp diode, called a flyback diode or a catch diode. So which component in here is causing the short? Well, if I go on the primary side, oh, by the way, there's a large inductor here, which is just a filter on the input side to reduce the noise, thrown back by the switching regulator back into the supply, to the DC source. But if I measure from ground again, if I measure from ground to this inductor, which is the input side of the switch, well, it's hundreds of ohms, more than 200 ohms. So the short is not on that side. These two capacitors are of a style that I haven't seen before. There's two, the plus and minus lead on one end, like as if they were a radio, and then there's a dummy lead on the back. But this, again, this is the output or the input filter capacitor, and across it, essentially more than 200 ohms, no problem. The output filter capacitor has two leads, plus and minus leads, and across it we measure the 2 ohm short. Likewise across the catch diode. Whoops. There we go. So the most likely problem is either this capacitor is shorted or the catch diode is shorted. And I'm going to bet on the catch diode, so I'll remove it and test it. Well, I lifted one end of the catch diode and put it on the trusty curve tracer, which says it's a short, and let's see what the ohm meter says too. Yeah, it's a 2 ohm resistor. And now, if I measure from ground to plus 5, I get way over 200 ohms. Let's go to the next scale. Okay, and measure here across this cap, which is the same thing. Ah. Okay, if I reverse the probes, I'll probably get another reading until the cap charges again. Okay, so the problem is the catch diode. I won that bet. Well, the catch diode, okay, some people will insist, purists will insist on calling it the flyback diode. It looks like a 3 amp diode. It looks a little bit like this 3 amp diode, but it, in fact, I looked it up, it's an 8 amp rated Schottky diode. And a Schottky diode has very low, well, much lower forward voltage drop than a silicon diode, and, which is what you want in this application. Every voltage drop is a power loss in a converter like this. So we'll have to replace it. I have to get a replacement 8 amp Schottky, and then we can reassemble it and try it. On this board, even though it doesn't show a short on the +5, it still blew those 2 fuses on the primary or in the secondary of the 18-volt source. So I strongly suspect, instead of the catch diode, which is there, I strongly suspect the switching transistor. Because if it shorts, there is a crowbar circuit. It's hard to put current limiting in a switching supply, so they opted to, instead of, if this transistor failed, the current limit might cut in. But in a switching supply, they put a crowbar on the output, so if the output rises too high, if this transistor is shorted, the SCR crowbar conducts. That will then blow the fuses and then protect the system. So I'm going to take this transistor out and check it. I've already checked it with an ohm meter, and it appears to be a short, collector emitter and base emitter and all that. So this is what it looks like on the curve tracer. That's not a transistor, that's a short. So the switching transistor is shorted. Now, as it says in the manual, to reinstall, reverse the procedure. Well, you have to get this board back in place. And maybe if I do it this way, I have to push this 3-terminal regulator out of the way, bend it out of the way, because it's okay. And now I can slide the board, move the 3-terminal regulator again. And I can slide the board over to its correct position. Reinstall all the screws, don't forget all the hidden ones. Okay, that's the last screw. Just double check all the places where there were screws. Okay, down here is the 3-terminal regulator. I need to put the screws back in it, and it has a mica washer behind it, so I'm going to make sure the mica washer is still there. And it's fastened with a flathead screw, a shoulder washer, a flat washer, and a nut. Now I'll put the other two screws of that, the other two This 3-terminal regulator. Both of these have mica washers behind them, and the mica insulators are still there. And have these two 3-terminal regulators bolted back in, and I'm going to check for short on the tab. Okay, the screw is shorted. The screw is grounded, but the tab is still insulated. Okay, this one screw is grounded. The tab is insulated. Now this third one, the one that's in this corner, the tab, I think it doesn't matter. The tab is grounded anyway. In fact, it is. So I don't know why there was a mica washer there. Maybe just to avoid ground loops. Now, next step is to reinstall and attach the other boards. There's no really good way to test this without putting it all back together, unfortunately. So, okay, the first thing to do is actually put on these. Okay, this direction, and install the rest of these harmonica jumpers. Sorry about that. I get this right here. Okay, now connect all the jumpers back to the board. Actually, maybe just as easy to put the screws back into the support first and then tilt the board out. They are kind of short, so now I'm going to pivot the assembly back and replace the two 440 screws that secure it. Now I can remove the screws that were holding the... Oh, before I do that, I should connect this cable underneath a large can cap. Making sure it's aligned properly. Now I can replace the remove these two screws. And replace the assembly. And it's a little tricky to get back in because of some interference. And on the side, some of the cables may be in the way. But eventually, should go back in place without too many complaints. Now I can resecure it with the flathead screws. Again, this is a number 2 Phillips, or two positive drive. I forgot to mention you could actually operate the scope with the back section. Oops. With the back section flipped up. You'd have to reconnect the ribbon cable. But the fan is not cooling everything. And it cools when the thing is in the normal position, so probably don't want to run it any longer with the back section flipped up than necessary. Now I'm going to reconnect the ribbon cable, which is not fun because usually these kinds of connectors have an opening that's the same width. The receptacle has an opening that's the same width as the plug portion. This one doesn't, so you have to get it centered properly and push it in. So that's how to do that repair.